Welcome to Bodishar Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose, or mouth with unwashed hands. Don't eat raw food. Thoroughly cook meat and eggs. Avoid contact with animal products. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Borishal Cadet College. Dear cadets, can you guess from the picture what we are going to discuss today? Here, 6 cube. Here 6 is base and 3 is exponent. And 6 cube is equal to, we can write 6 into 6 into 6. Normal representation. And here a to the power 1 by n and a to the power m by n. So our today's topic is exponential from chapter 9.1 of your book. Learning outcome. After the class, the cadets will be able to explain exponent, explain and apply the law of exponent, solve exponent related problem. Firstly, we recall some notations. Here are denotes the set of natural number, set of real numbers. Here set of real number means all the rational and irrational numbers. Here rational and irrational number means 0, plus minus 1, plus minus 2, plus minus 3, plus minus half, plus minus 3 by 2, root 2, root 3, root 7, etc. And n denotes the set of natural numbers. Here set of natural number means 1, 2, 3, 4, 5, 6, etc. And z denotes the set of integers. Here set of integers means all positive and negative fractionless numbers are said to be integers. That means minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. Q denotes the set of rational numbers. Here set of rational number means the numbers of the form p by q are called the rational number when p and q are integers and q is not 0. If a is any real number and n is any natural number, when a is multiplied n times, the product is written as a to the power n is equal to a dot a dot a dot 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 n times, and a to the power n is called nth power of a. In such case, a is called the base and n is called the exponent or index. Now we repeat this term again. If a is any real number, a is any real number, and n is any natural number, and n is any natural number. When a is multiplied n times, the product is written as a to the power n is equal to a dot a dot a dot dot n times, and a to the power n is called nth power of a. In such case, a is called the base and n is called the exponent or index. Example, in 3 to the power 4, the base is here, the base is 3 and 4 is exponent. Definition, for all a belongs to R, number 1, a to the power 1 is equal to a, and a to the power n is equal to, we can write a dot a dot a dot dot n times factor of a, where n belongs to n and n greater than is equal to 1. Now, laws of exponents. If a belongs to R and n belongs to n, here R means set of real number and n means set of natural numbers. Then a to the power 1 is equal to a, and a to the power n plus 1 is equal to, we can write a to the power n dot a. Here a to the power n means the a to the power n is the product of n factors, and a means a to the power 1. Then n plus 1 is a to the power n plus 1 is equal to, we can write a to the power n into a. For every a belongs to R, here R means set of real number, and mn belongs to n, n means set of natural number, then a to the power m into a to the power n is equal to, we can write a to the power m plus n. Here a to the power m means the product of m factors, and a to the power n means the product of n factors. Then we can write a to the power m plus n. And a to the power m divide a to the power n is equal to, we can write a to the power m minus n, or m minus n. For every a belongs to R and a is not 0, and mn belongs to n and m is not n, then we can write a to the power m by a to the power n is equal to a to the power m minus n, where when m greater than equal to 1, and a to the power m by a to the power n is equal to 1 by a to the power n minus m when m less than n. If a belongs to R and mn belongs to n, then a to the power m to the power n is equal to a to the power mn. For a, b belongs to R, here R means set of natural number, and n belongs to n, n means set of R means set of real number, and n means set of natural numbers. Then a into b to the power n is equal to, we can write a to the power n into a to the b to the power n. Now another formula, a by b to the power n is equal to, we can write a to the power n by b to the power n. If a greater than 0 and m belongs to z and n belongs to n, and n belongs to n greater than is equal to 1, then we can write root of a to the power m is equal to n root of a to the power m. Now some important facts. If a to the power x is equal to 1, where a greater than 0 and a is not 1, then we can write x is equal to 0. If a to the power x is equal to 1, where a greater than 0 and x is not 0, then we can write a is equal to 1. If a to the power x is equal to a to the power y, where a greater than 0 and a is not 1, then x is equal to y, x is equal to y. If a to the power x is equal to b to the power x, where a by b greater than 0 and x is not 0, then we can write A is equal to B. Remember these things. Now we can try to solve some problems. Prove that a to the power m by n to the power p is equal to a to the power mp by n, where mp belongs to z, z means set of integers, and n belongs to n. Here n means set of natural number. Here n means set of natural number, and z means set of integer. Now solution. Let a to the power m by n is equal to x. Then we can write a to the power m into 1 by n is equal to x. We know a to the power 1 by n is equal to x. Then we can write a is equal to x to the power n. Applying this formula here, then we can write a to the power m is equal to x to the power n. This is number 1. And a to the power mp by n is equal to y. Let a to the power mp by n is equal to y. Then we can write a to the power mp into the power 1 by n is equal to y. Same formula here we use. Then we can write a to the power m into p is equal to y to the power n. We know a to the power m is equal to x to the power n from 1. Putting this value here, then we can write a to the power m is equal to x to the power n to the power p is equal to y to the power n, or x to the power p to the power n is equal to y to the power n. Here n and cancel, then we can write x to the power p is equal to y. Thus a to the power m by n is equal to x, and a to the power mp by n is equal to y. We know this term. Now putting this value here, then we can write a to the power m by n to the power p is equal to a to the power mp by n. Good. Now another question. Prove that ab to the power m by n is equal to a to the power m by n into b to the power m by n, where m belongs to z and n belongs to n. Now let m by n is equal to x. Now left hand side, ab to the power m by n. Now putting this value here, then we can write ab to the power x, m by n is equal to x. We know the formula. ab to the power x is equal to, we can write a to the power x into b to the power x. Now putting the value of x here, then we can write a to the power m by n into b to the power m by n. This is our required proof. Now another question. Show that a to the power 1 by 3 minus b to the power 1 by 3 into a to the power 2 by 3 plus a to the power 1 by 3 b to the power 1 by 3 plus b to the power 2 by 3 is equal to a minus b. Now solution. Here given that left hand side a to the power 1 by 3 minus b to the power 1 by 3 into a to the power 2 by 3 plus a to the power 1 by 3 into b to the power 1 by 3 plus b to the power 2 by 3. Now here we can write a to the power 2 by 3 is equal to, we can write a to the power 1 by 3 into square, and b to the power 2 by 3 is equal to, we can write b to the power 1 by 3 to the power square. Now we know a minus b, a cube minus b cube is equal to a minus b into a square plus ab plus b square. applying this formula here, then we can write a cube minus b cube, because we here a cube, a means a to the power 1 by 3 and b means b to the power 1 by 3. Here a minus b into a square plus ab plus b square is equal to a cube minus b cube. Now 3 cancel, here 3 cancel, then we can write a minus b. This is our required proof. Now another question. A cube plus 1 by a cube is plus 1 by a to the power 3 by 2 plus a to the power minus 3 by 2 plus 1 is equal to a to the power 3 by 2 plus a to the power minus 3 by 2 minus 1. Solution, left hand side, this term. Here we try to use formula. That's why we can write a cube plus 2 plus a to the power minus 3 minus 1. Then we can write a to the power 3 by 2 to the power square. Here 2 to cancel. That means a cube, and plus 2 into a to the power 3 by 2 into a to the power minus 3 by 2. Here minus 3 by 2, that means a to the power minus 3 by 2 minus 3 by 2. Cancel, that means 2. And plus a to the power minus 3 by 2 to the power whole square and minus 1. Here the same term. Now we see here a square plus 2ab plus b square is equal to, we can write a plus b whole square. Here a means a to the power 3 by 2 and b means a to the power minus 3 by 2 and minus 1. Here a to the power 3 by 2 plus a to the power minus 3 by 2 plus 1. Now another formula. Here a square minus b square. We know a square minus b square is equal to a plus b into a minus b. Now putting this formula here, then we can write a plus b. That means a to the power 3 by 2 plus a to the power minus 3 by 2 plus 1 into a to the power 3 by 2 plus a to the power minus 3 by 2 minus 1 by a to the power 3 by 2 plus a to the power minus 3 by 2 plus 1. Here this term and this term are cancelled. Then we can, the remaining term a to the power 3 by 2 plus a to the power minus 3 by 2 minus 1. This is our required proof. Now another question. Simplify a plus b by b to the power a by a minus b into a minus b by a to the power a by a minus b divided a plus b by b to the power b by a minus b into a minus b by a to the power b by a minus b. Solution. Given that this term, now we separate same base term, that means a plus b by b and a plus b by b to the power a by a minus b, b by a minus b. Here the same base a minus b by a and a minus b by a to the power a by a minus b and b by a minus b. We know a to the power m by a to the power n is equal to a to the power m minus n. Here this formula we use here, then we can write a plus b by b to the power m minus n. Here m means a by a minus b and n means b by a minus b. That's why we can write a plus b by b to the power a by a minus b minus b by a minus b into a minus b by a to the power a by a minus b minus b by a minus b. Use this formula here, then we can write this term. Now LCM a minus b, then we can write a minus b by a minus b. Here LCM a minus b. Then we can write a minus b. Here a minus b by a minus b is equal to 1, and a minus b by a minus b to the power 1. That's why we can write a plus b by b to the power 1 into a minus b by a to the power 1. Now the remaining term a plus b by b into a minus b by a. Now multiplying this term, then we can write a plus b into a minus b is equal to, we know, a square minus b square, and a into b, that means ab. This is our required answer. Now another question. Simplify 1 by 1 plus a to the power minus m b to the power n plus a to the power minus m c to the power p plus 1 by 1 plus b to the power minus n c to the power p plus b to the power minus n a to the power m plus 1 by 1 plus c to the power minus p a to the power m plus c to the power minus p b to the power n. Given that this term, then we can write 1 by, here a to the power minus m means 1 by a to the power m. That's why we can write b to the power n by a to the power m. And the same way we can write c to the power p by a to the power m. Here we can write 1 plus c to the power p by b to the power n. Here a to the power m by b to the power n. And here c to the power minus p, that means 1 by c to the power p. That's why we can write a to the power m by c to the power p and b to the power n by c to the power p. Now LCM a to the power n, then here LCM a to the power m, and here LCM b to the power n, here LCM c to the power p, here a to the power m, then we can write a to the power m plus b to the power n plus c to the power p, and b to the power n plus c to the power p plus a to the power m, here c to the power p plus a to the power m plus b to the power n. That's why we can write a to the power m plus b to the power n plus c to the power p by b to the power n LCM b to the power n, b to the power n plus c to the power p plus a to the power m by c to the power p plus a to the power m plus b to the power n. Now exchange this term, then we can write 1 into a to the power m by a to the power m plus b to the power n plus c to the power p into 1 by b to the power n c to the power p a to the power m plus 1 into c to the power p by c to the power p plus a to the power m plus b to the power n. Then we can write a to the power m by a to the power m plus b to the power n plus c to the power p. Here we can write b to the power n by a to the power m, b to the power n, c to the power p. And here we can write c to the power p by a to the power m plus b to the power n plus c to the power p. Here LCM this term. Then the remaining term we can write a to the power m plus b to the power n plus c to the power p. This term and this term are cancelled. That's why we can write 1. This is our required answer. Now another question. If x is equal to a to the power q plus r b to the power p, y is equal to a to the power r plus p b to the power q, z is equal to a to the power p plus q b to the power r, show that x to the power q minus r, y to the power r minus p, z to the power p minus q is equal to 1. Now given that this term and left hand side this term. Now putting the value of x, y and z here, then we can write x means a to the power q plus r b to the power p to the power q minus r, y means a to the power r plus b b to the power q to the power r minus b, and z means a to the power p plus q b to the power r to the power p minus q. Now multiplying this term, then we can write, we know a plus b into a minus b is equal to a square plus b square. That's why you can write a to the power q square minus r square into b to the power pq minus pr. Here r plus p into r minus p. That's why you can write a to the power r square minus p square into b to the power qr minus pq into a to the power p square plus q square into b to the power rp minus b to the power rq. Now we arranging same term, a to the power q square minus r square, a to the power r square minus p square, a to the power p square minus q square, and b to the power pq minus pr, b to the power qr minus pq, b to the power pr minus qr. Now we know here the same base a. Now we can write a to the power q square minus r square plus r square minus p square plus p square minus q square, and b. Here this same base we can write b to the power pq minus pr plus qr minus pq plus pr minus qr. Here q square cancel, p square cancel, r square cancel. That's why we can write a to the power 0, and here this term are cancelled. That's why you can write b to the power 0. We know a to the power 0 is equal to 1 and b to the power 0 is equal to 1. 1 into 1, that means 1. This is our required answer. Now a to the power x is equal to p and a to the power y is equal to q, and a square is equal to p to the power y, q to the power x to the power z, so that x, y, z is equal to 1. Solution: given that this term, and here a square is equal to p to the power y, q to the power x to the power z. Here we can write p means a to the power x. Now putting this value here, p means a to the power x and q means a to the power y to the power x. Now xy, multiply this time, that's why you can write a to the power xy into a to the power xy to the power z. Now we know the same base, then we can write a to the power xy plus xy to the power z. That's why you can write a square to the power a to the power 2xyz. Now here a and a are same base. That's why we can write 2xyz is equal to 2. Here 2 to cancel. That means we can write xyz is equal to 1. This is our required proof. Now this is your homework. Prove that a to the power 1 by m to the power 1 by 2 is equal to a to the power 1 by mn, where mn belongs to z. Simplify a square minus b to the power minus 2 to the power a into a square plus b to the power minus 1 is equal to into b minus a by b square minus a to the power minus 2 to the power b into b plus a inverse a to the power minus 1 is equal to into a minus b. If a to the power p is equal to b and b to the power q is equal to c and c to the power r is equal to a, then show that pqr is equal to 1. This is your homework. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing. In this critical situation, you must stay home and keep yourself safe. Stay fine. Thank you.